So hello everyone, welcome to OneClass YouTube channel. My name is Devansh and I'm a senior tutor at OneClass. So today we are going to go through a couple of few popular mathematics question and answers and a little bit background about myself. So I am in the final year of my graduation and I'm doing it in the aerospace engineering. So if you have any question answers or if you want any tutoring help or one-to-one sessions, then you can check the links in the description below. And without wasting time, let's just start with the questions. So here we have question number one. So it states that how do you find tangent inverse of negative of 1 without using any calculator? So tangent inverse of negative 1. We need to find the value of tangent inverse of negative of 1. And let's see what the solution is given here. First, we need to recall that the inverse of a tangent function is basically arctangent function. So if y is tangent of x, this implies x will be tangent inverse of y. Now we know that the mm, wait a minute. Yep. So we know that the tangent of pi by 4 is 1, and suppose if we have a unit circle, then let's say I'll just take this line and I'll draw a unit circle here. X, negative y, negative x, and at this point of a unit circle we have the coordinates as 1 over root 2 comma 1 over root 2, and this is positive of pi by 4. So when we go to negative pi by 4, this is minus of pi by 4 because we are going in the clockwise direction. Then the x coordinate remains positive, but y coordinate changes to negative. Now if I take tangent of negative of pi by 4, this will be y by x, and this will be 1 over root 2, negative of 1 over root 2, and this will be equal to negative of 1. So basically it states that tangent inverse of negative of 1 was to negative of pi over 4, and that is pretty much if we want we can take one more angle. So at this point the coordinate will be negative of 1 over root 2, and this angle will be pi by 4, pi by 4, pi by 4. This will be 3 pi by 4. Tangent of 3 by pi by 4, again y by x, and it will be so This should be negative and this should be positive here. So in this case, we have positive of root 1 over root 2 and negative of 1 over root 2. So this also gives us negative 1, which states that tangent inverse of negative of 1 can also be 3 pi by 4. This can also be 3 pi by, yep. And one solution was this, one solution was this. So I can write it like tangent inverse of negative of 1 is 3 pi by 4 or negative pi by 4. Solution given here is correct. Great job. Arc tangent of negative of 1 is also 3 times pi by 4. So here half solution is missing, but that is okay because 3, 4 and negative pi by 4 are the correct solution. So we'll go to question number 2. So it states that what is the definition of standard form? Standard form. So let's see the definition given by the junior tutor. So the standard form of exponential numbers is a way to shorten large numbers using the powers of 10. We can write the standard form by moving the decimal place up to the first integer of the number, and the number of times the decimal place is moved uh, is the number of times you multiply the number by 10. For example, we need to write the standard form of 819 and a lot of zeros. In standard form, this is written as 8.19 into 10 power 3. Since we move the decimal places 13 times, we are multiplying 8.19 by 10 power 3. So in suppose we have a number, say let's say we have 2 1 3 4 7 8 0 0 0 0, and the decimal place, let's say this is the number. Then instead of writing this whole big number, what we can do is that we can write 2.134, and we can say 1 2 3 4 5 6 7 8 9. So we are placing the decimal at this point. So after decimal we have 9 numbers. So we will write it like this. So we'll just raise the that number to the number of raise the power of 10 to the number of integers we have after the decimal place. So again, if I go for second example, so let's say we have 1 2 3 4 5 6 7 8 9 10. Then again I can write it like 1.234 into 10 power 1 2 3 4 5 6 7 8 9. Yeah. So this is the kind of notation which is mostly used in engineering terms or in scientific calculations. So this is a basically a way of shortening the number so that it is easier for all of us to just remember the number basically. So again, the solution given here is correct. What is this? Correct solution. Great job. And the solution is correct. So question number 3 is, what are double angle identities? So double angle identities. So suppose the double angle identities we have. So suppose let's say I want to calculate let's say I want to calculate sine of 60 degree, and I have the value of sine of 30 degree, which is half root 3 by 2, and we have cosine 30 degree, which is root 3 over 2. So I know the sine of 60 is basically root 3 over 2. So I will try with the identity of sine 2 into 30, which is 2 times sine of 30 into cosine of 30, which will be equal to 2 times 1 over 2 times root 3 over 2. This 2 and 2 can get cancelled and it will be root 3 over 2. In the similar fashion, I know the value of cosine 60 is also 1 by 2. So if I use double angle identity of cosine, then for cosine we have 3 identities. So I'll just start with the first one. So it is cosine squared 30 minus sine squared 30. So cosine squared 30 will be root 3 over 2 whole square, minus sine square will be over 4 minus 1 over 4, which is 2 over 4, 1 over 2. Again using the second identity for cosine, this time we are going to use 2 times cosine square of 30 degree minus of 1, 2 times root 3 by 2 whole square minus 1. This is going to be 2 times root 3 by 2 times 2 times root 3 minus 1. This will be 3 over 2 minus 1. If I take the LCM, so this is again going to be 1 over 2. So again cosine 60 is 1 over 2. So now we are going to move for the third identity, which is 1 minus 2 times sine square of 30 degree. 1 minus 2 times 1 over 2 into 1 over 2. And this 2 can get cancelled. So we have 1 minus 1 over 2, which is going to be 1 over 2. again cosine 60 is again 1 over 2. Now for going for tangent, so tangent of 60 I know is root 3, and tangent of 30 is 1 over root 3. So let us calculate. Tangent of 2 times 30 degree is going to be 2 times tangent of 30 degree over 1 minus tangent square of 30 degree. This is going to be 2 times 1 over root 3 over 1 minus 1 over root 3 whole square. This will be 2 times 1 over root 3 over 1 minus 1 over 3. If I take the LCM, this will go here. So this will be 2 over root 3 over 3 minus 1 over 3. 2 over root 3 over, this will be 2 over 3. So I can cancel this 3, this 2 and 2, and this will become 3 over root 3, which is basically square root of 3, and tangent of 60 degree is square root of 3. So in this way we can calculate the tangent, use double angle identities to calculate the tangent, sine and cosine of those angles uh, who are multiple of, like, if you want to calculate for 60 we can use 2 times 30. If you want to calculate for 120 we can use 2 times of 60, and in such a way we can use these double angle identities. So correct solution. Great job. And let's move for the next question. This was 1, 2, 3, 4. We need to find the following system of linear equations has many solution. So the condition is infinite solution of system of linear equation and let's look at those equations. The equation is 6x plus 4y minus 3z equals to negative of 7. Then 6x minus 6y plus 5z equals to negative of 9. 6x minus 16y plus hz equals to k, and we need to find the value of h and k so that these three equations have infinite solutions. So let me first write, let's say this is equation 1, this is 2, and this is 3. So for a system of linear equations to have infinite solution, um, these so these basically are they lie on a same line. So all these three equations are going to lie basically on the same line to have infinite solutions. So for that case, what we are going to do, we are going to subtract second equation from the first one. So the second equation is 6x minus 6y and then plus 5z equals to negative of 9, and the first equation was 6x plus 4y, then minus 3z equals to negative of 7. I will subtract plus plus. So this x will get cancelled, so we have 0x, then we have negative of 10y, then we have positive of 8z, and this is going to be negative of 2. Let's say this equation as 4. Now we are going to subtract second equation from third. So third equation minus second. The third equation is 6x minus 16y plus hz equals to k, and second one was 6x minus 6y plus 5z equals to negative of 9. So I will subtract, this will become plus, minus and plus. So again this will be 0x, and this will be minus of 10y. This will be h minus 5 times z, and this will be k plus 9. And let's say this equation as equation number 5. Now we have two equations, equation 4 and equation 5, and these equations are going to be the same equations. So basically for the condition for infinite solution is that fourth equation should be equal to fifth equation, which means that my coefficient of x, say coefficient of x for fourth equation will be equal to coefficient of x for fifth equation, then my coefficient of y for fourth equation will be equal to coefficient of y for fifth equation, and in the similar manner for z also and for constant. So basically we are going to compare these two equations. So we have negative of 10y equals to negative of 10y, which is true. Then for z we have 8z equals to minus 5, and I can add 5 on both the sides. So h is going to be 13, and we have k plus 9 equal to negative of 2. So I will subtract 9 from both the sides and I will get, so this will be negative of 11. So let us see, we have h is 13, this is 13. Sorry, I'll just rewrite it. And we have k as negative of 11. So this is correct solution. I'll go for good book this time. So this was question number 4. I will go for question number 5. We need to find the square root of 300. So first I will start with radical form. So 300 can be written as 3 into 100, and this can be written as 3 times 10 times 10. I can just separate them. So I have this pair, this can come out of square root. Now this is the most possible radical form, or we cannot split 3 into further prime numbers. So either we can leave it like 10 root 3, or we can just multiply it with the value of root 3, and root 3 is approximately 1.732. So this will be 17.32, and this will go on further. So if you have any calculator, you can just write the exact solution, or if you do not have the calculator, if you just want to simplify it, then you can write it in the way 10 root 3, or let's see. Yep, so 10 root 3 is the correct answer. So the solution given by Junior Tutor is correct here, and solution is correct. This was question number 5. Question number 6. So we need to find the derivative of square root of x. We need to find derivative of square root of x. So for this, I will use the identity like the derivative of x power n is basically n times x power n minus 1. So in this case, I can write root x as x power 1 by 2. Then I have derivative of x power 1 by 2 will be equal to, using this rule, 1 over 2 x power 1 over 2 minus 1. This will be 1 over 2 x power negative of 1 over 2, and this will be x power 1 over 2, or 1 over 2 times square root of x. So this should be the solution for derivative of square root of x. So the derivative of square root of x, which can be mathematically written as ddx of square root of x. Again, here also they have used the same identity. So and then we have n times x minus 1, 1 over 2 x power negative of half, and this will negative power will come in the denominator and it will become positive. So I have final answer as 1 over 2 times square root of x. Correct solution. Nice work. So this was question number 6, and this is going to be question number 7. We need to convert negative of 0.875 as fraction. So let us first see the procedure given here. So converting negative of 0.875 to a fraction. Note that negative of 0.875 is read as negative 875,000. Well, this is wrong because after decimal place, we read each and every integer like a separate integer, not like 875,000. We read it like 0.875. The first digit after the decimal represents the tenth place. The next digit after the decimal represents hundredth place, while the third is the thousandth place. To convert to fraction, first we count the number of digits and after the decimal points we have 0.875. In this case we have 3, therefore n is equals to 3. And then we remove the decimal and divide the number by 10 power n, where n is the number of digits after the decimal point. So the number we had was negative of 0.875. Now we have 1, 2, 3 digits after decimal. So what we are going to do is that we are going to multiply 10 times the number of digits. So we have 3 digits and we cannot just multiply, so we need to divide it with the exact same number. Now this will become negative of 0.875 times 1000 over 1000. Now when we multiply 0.875 with 1000, this number will become negative of 875, because the decimal will be vanished, or it will just go away because it is multiplied by 1000 and we have the denominator here. Now we need to simplify this fraction because this is a very huge number. So let's just see. If I go for prime factorization, then we will have for 875 we'll have 1 Then this is going to be 37, 7 times 25, 5, 5. This is going to be 3 times, and this is going to be this will be 3 times 17, 15, 3, 35. This is going to be 7, and I'm not sure that I have made any mistake at this point. So I had 1 time, and we have 37 5 time, then we had 25, um, so 25 was 5 time, and 17 we have 3 times, and for um, this one is 17 3. Okay, yeah, I got my mistake. So this will be 3 times, and 2 will carry, so this will be 5. 5 times 7, 7 times 1, for 1000. This will be 5 times 200, 5 times 40, 5 times 8, 2 times 4, 2 times 2, 2 times 1. So we can write 875 as 5 into 5 into 5 into 7, and we can write 1000 as 5, 5, then we have 3, 2, then we had a negative sign here, so a negative sign will come here. Now we can cancel this 5, this 5, this 5, and we'll be left with negative of 7 over 2 times 2 times 2 will be negative of 7 over 8, and this is going to be the simplest or the simplest fraction of uh, our number. So negative of 0.875 is negative of 7.8 in terms of fractions. So the answer given by Junior Tutor is correct, and therefore this is correct solution. Very good. So this was question number 7. This is going to be question number 8. I will start writing this question number on this at this point, at this place. So we need to write what is the equation of a sphere in standard form. So we need to write equation of sphere in standard form. Well, I'm not sure that I can draw a sphere completely, but equation of sphere uh, resembles a lot with the equation of circle. So suppose a circle is a 2D. This is not a perfect circle, but let's just say um, let's just say as this is a circle and this is the center point, and let's say coordinate of center point is h comma, oh god, this is h comma k, and the radius is r. Then the equation for circle was x minus h whole square plus y minus k whole square equals to r square. Now a sphere is a three-dimensional body, so let's just say there is one more dimension like this, and in the z direction we have the coordinate. So my center coordinate is not only going to be h comma k, it is going to be h was for x, k was for y, and for z I have l. Radius is going to be the same, so equation of sphere will become h minus x minus h whole square plus y minus k whole square plus z minus l whole square equals to r square. And this equation is for sphere, this is for circle. This is a 3D shape and this is a 2D shape. So let's see the solution provided by Junior Tutor. So it is the equation of sphere in the standard form is given as h minus h whole square plus y minus k whole square plus z minus l whole square equals to r square. So the solution given by Junior Tutor is correct. Great job. And the solution is correct. Now this was question number 8. I will move for question number 9. We need to draw the graph of f of x equals to x square. So by looking at this equation, I can like say that this equation is the equation of a parabola, and we are going to get a parabola in this case. And let's say f of x as y, because it is easier in terms of y rather than again and again calling it as f of x. And what we are going to do is that we are going to find the value of y when x is 1, something like this, and here we have x, here we have y. So for, let's say for x equals to let's say -2, then we need to find for -1, then 0, then 1, then 2. So for x equals to -2, we'll have y as 4. For x equal to negative of 1, we will have y as 1. For x equals to 0, we have 0. For x equals to 1, positive 1, we have again y equals to 1. Then for x equals to 2, we have y as positive 4. So we can see here that whatever value we give for x, whether it is negative or positive, we always get y as a positive number. Now we are going to draw the axis. So let us say I will just undo this axis. I'm going to create this axis with blue color, and this is like this. Okay, now we had for x we had -2 to +2. So this is x-axis, this is y-axis. Let's say this as 0, and these are the coordinates. So this is negative of 1, negative of 2. Let's say this as 1, this as 2. And let's just find the value of y for -3 and +3. So for -3 it is going to be 9, and for +3 is again going to be 9. So it is better if you have more coordinates, because it will help you to like create a better curve. So, and for y we had from 0 to 9, and we have only for positive values. So 0, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So I will mark for 1, then 2, 3, 4. I will mark for 4, and I will mark for 9. Now for x equals to -2, we had y as 4. -2, we had y as 4. So this point will come somewhere here. Then for x equals to -1, we had 1. So this will come somewhere here. I need one -3 and one +3. So let's say this as 1, 2, 3, 4, 5, 6, 7 coordinate number, and this is going to be, this was 1, this is 2. For x equals to 0, we had y equal to 0. So this is going to be my third coordinate. For x equals to 1, we had y as 1. So this will come somewhere here. This is fourth coordinate. For x equal to 2, we had y as 4. This will come somewhere here. And for x equals to -3, we had y as 9. This will be sixth. And for x equals to +3, we had y as 9 only. So this is seventh coordinate. Now I will try to join these lines. I'm not sure that I will be able to do it properly. Um, and this will go till here. So my drawing is not that much good. So this curve is not looking like an actual parabola, but actually it is the equation of a parabola, and this curve is going to look something like this when we draw this curve in a proper grid system, not like mine, which I have drawn not properly. And the vertex of this parabola is at 0 comma 0. So the solution provided here is, I haven't seen the solution yet. So the function f of x equals to, let's say it as y, which is equals to x square, is a quadratic equation which has a parabolic graph. Its vertex is located at the origin 0 comma 0. We can plot other points of this graph by using any value of x and finding its corresponding y value. So for x equal to 0, we had y is 0, for 1, 1, 2, for 4, and for 3 we have 9. So this is correct solution, and let's go for good work. And solution is correct. Now we had, this was question number 9th, I think, yeah. So this is going to be the question number 10. So for question number 10, we have what we need to do is that we need to draw the graph of y equals to sine x plus 1 in the interval of 0 to 360 degree. Now, before starting this question, I know that how a sine wave or how a sine graph looks like. It is the periodic graph, like for 0 we had the 0, and it is something like this. So it is a periodic graph, but we do not have it's not just like y equal to sine x, we have 1 also. So we'll go with the proper solution. So let's just go through the solution given by Junior Tutor. So the basic formula for sine curve is represented by y equals to a times sine of b times x minus k plus c, and we have magnitude a is the amplitude, the period 2 pi over magnitude of b. It's basically the period of this harmonic, and we have k as horizontal shift, and we have c as vertical shift. But this is just the equation or everything is just put in the word form. But if you want to actually imagine everything, what we do is that we can do one thing. So we can find the values of x, find the values of y for different values of x, and with that we can just get an idea like how my graph is going to look like. Well, before just writing the question, I knew that how the graph is going to look like, but um, I'll just draw a table, one line, on this. Now my interval is from 0 to 360. So let's write x and y. Let's go for 0. Then let's go for 45. Then for 90. Then 135. Then 180. And then this will be 225. And it was 220. Yeah, it will be 220. 70, I think it is going to be 305. Let me just make sure. 270 plus 45 is 315. Yup. So we have 315 and we have 360 finally. And the equation was sine of x plus 1. So x is here in degrees. And for y, let's just start with this first value. So y equal to sine of 0 is 0 plus 1, which will be 1. Sine of 45 is 1 over root 2 plus 1. So this will be 1 over root 2 plus 1, 1.707. Then for 90, we have sine 90 is 1, then 1. We have 2. For 135, sine of 135 is again 1 over root 2 plus 1. So this will be again 1.707. Then sine 180 is 0. We have plus 1. So this will be 1. Then for 225, sine of 225 is negative of 1 over root 2. Negative of 1 over root 2 plus 1. So plus 1, this will be 0.292. For 270, sine of 270 is negative of 1 plus 1. This will be 0. Then sine of 315 is again negative of 1 over root 2 plus 1, and this will be 0.292. And sine of 360 is 0. Sine of 360, I think, yep, it will be 0. Yep. So let's just go for the axis. and quickly I'll just write 0 degree in x, this 45, 90. I'll go for 90 only directly, then 180, 270 and 360, and for y I have from 0 to 2. So 0, then I have 1, I have point, I have point 0.29, then I have 1.7. Oh, sorry, this will come here. Then I have 1.7, and here I have 2. So I will draw the coordinates quickly, and for 0 I have 1, then for 90 I have 2, for 180 I have 1, then for 270 and 360 I have 0. This should be 1, not 0. This should be 1 because it was 0 plus 1. So for 270, 0, and for 361, for 360 we have 1. So it will look something like this, but the actual graph is going to look like this. And this is the graph for originals y equal to sine x, and the vertical displacement here we have is 1. This c is the vertical displacement. So my whole curve of y equal to sine x is going to be shift vertically upwards by 1 unit. So this is a better looking graph, and mine one doesn't looks like a lot good. Yeah. So this is correct solution. Good job. So this was all for this session, and if you like this session, then please do mention in the comment section below. And if you want to submit your own questions, or if you want one-to-one live sessions or tutoring help, then you can check in the links in the description below. And this was Devansh Purohit, senior tutor at OneClass, and I hope to see you soon in my next video. So till then, bye.